Students, so today we did a good portion of the MergeSort activity and we completed writing the main file for the assignment, and we went over writing the pseudocode for a selection sort algorithm. So with all of that done, this video will cover the three main portions of what our MergeSort function will accomplish. I've written them in this comment section. Here we can see that first it will divide the array into two half-size arrays, array 1 and array 2. Then we will sort array 1 and array 2 in ascending order from lowest to highest using a selection sort algorithm. And then third, once we have sorted the two smaller arrays, we will merge array 1 and array 2 into a sorted list by repeatedly adding the smaller element at the beginning of each array. So array 1 and array 2. So in the end, we will have an array of int size that is sorted. So the first thing we're going to need to do is to divide the array that we pass as an argument in the function. We're going to need to split this array into two small arrays. So the first thing we're going to do is to declare variables for this, the sizes of two half-size arrays. So sorry about that. Let's do that right now. And I'm just going to fix this really quick so you can see me. There we go. So we want to declare the half size of the array, and let's make two variables that will be half1, and half1 will correspond to the size of array 1, and half2 will correspond to the size of array 2. So we declare these size variables for the two smaller arrays, and then what we want to do is we want to figure out, based on whether the size of the array we pass in is even or odd, what values these two halves should be. For example, if we're given an odd size array like 9, one of these halves will have to be 5 and the other one will have to be 4. So let's test to see if the size is even, and we can do that by using the modulo 2. And if there's no remainder when you divide by 2, that means that the number is even. So if the size that we're given is even, we will basically divide the size in half and assign it to each of the half variables. Okay, and if the size is odd, then I'm going to arbitrarily just make the first array one element larger than the second array. So this is in the case, for example, you're given an odd array, let's say of 9. So this will be half1 will be 5 and half2 will be 4. Okay, so we figured out how to basically create the sizes for the two small arrays. Now let's just declare those arrays. So we'll have an integer array called array 1, and that will be of size half 1. And we'll do the same but for an array called array 2, and that will be of size half 2. Awesome. Now we have these arrays, and let's fill them with some numbers that are provided in the array that we receive as an argument in this function. So we should start out, we can basically do it in two ways. One way was that we just use two for loops, one for the first array and one for the second array. So let's try that out. Let's do the first array first, and we'll create an index variable I, and while it is less than the size of the first array, now what we'll want to do is we will assign the first array at the index to the value of the array. So this is the array that's passed into the function. That's basically the full size array, and we'll get its element at that same index. So this will give us the first half of numbers from the parent array and put them in array 1. And if we're going to do the same thing for array 2, we just need to understand where we want to start our index variable. So this for loop will populate the second array with numbers from the parent array. So we're going to want it to start at a number that is not 0. We'll want it to basically start where the size of half 1. So let's say half 1 is in a total size array of 9. Let's say half 1 has 5 items and half 2 has 4 items. So we'll want to start at the, for example, 5th item. So we'll want to set I equal to half 1 in this case, and while I is less than the size of the parent array. And that will give the remaining values to the array, the second array. So array 2 at I equals array at I. Great, so now we have two smaller arrays filled with the items from the parent array. Now it is time to implement the selection sort algorithm. And I will walk through how we would want to do the selection sort for the first array, and then your goal would be just to implement it for the second array by yourself. So we already in class have reviewed what selection sort does in terms of looking for the minimum element and then swapping it with the first index, and then basically doing the same thing, trying to find the second smallest element, but now looking in, let's say, the first index of the array, and then swap again. So again, you could look up the selection sort algorithm and get a visual understanding of what it's doing online. We covered it already in class, so I'm not going to spend too much time talking about giving an example of like an array and drawing through it. So the first thing we're going to want to do is to declare a minimum variable and a minimum index variable. So those will both be ints, and we can say int min and int min index. So min will hold the minimum element we're looking for at a time, whereas min index will hold the index of where that minimum element lives in the array. And we're going to loop through the first array, and we assume that the minimum is equal to the first element in array 1. So we're going to assign min to array of start, and the next thing we're going to need to do is compare this starting index against all the other remaining indexes in the array. So in our nested for loop, which will be the comparison loop, we will create another index variable, we'll call it I, and we want to set it equal to the next element. So whatever is after start's value. So we'll set it to start plus 1. So we'll look at the next element in the array, and then we'll continue until we are at the end of the first array. And then I'm going to copy these comments. Great. So now our goal is we want to identify if we find an element at this I index that is less than the min. So for example, we set the 0th element originally equal to min, and if we find any other elements that at index I that are smaller than min, we will update min. So we can write an if statement that basically says if the array 1 at I is less than min, we will reassign min to that element. So array 1 at I. And another comment we have here is that we want to save the index of this element. So this will save the number itself. Like let's say the next minimum number is the number 7. And let's say the number 7 was at index of 4. We want to save both the number 7 and its index that it was stored at. So we'll assign min index to I, because that is the index that we found the minimum number at. Great, so let's make sure now we'll want to swap the indexes of the new min element and the current index we are at. So let's make sure that we are outside of the comparison for loop when we do this. So we want to copy this comment and put it underneath this inner for loop. So by the time that this for loop has ran, we will have found the next minimum element, and we can now swap that min element at the start index that we are currently at. So basically, we want to replace this starting index with the min value we just found. And we want to assign the element that was at the start index to the location where we found the minimum element. So in order to do that, let's get the index, let's get the array at the min index and assign that to, so this is the element that we, this is the minimum element that we found. And we're going to replace that with the number at the start. So array of start. And then what we can do is we need to replace the array at the element at the start with the new minimum. Sorry, I'm getting really distracted because my telephone just keeps on ringing over and over again. So I kind of want to get that, but I will wait until the end. But it is annoying the crap out of me. So this will implement selection sort for the first array. And you can do the same thing for array 2, but just keep in mind that you'll need to declare new variables for the minimum and the min index. You can just call it minimum min2, min index 2, and then you'll want to be using the half 2 and array 2 when you're sorting the second array. Okay, finally, we'll assume that this array has been sorted, and our third goal is to merge the two sorted arrays into one larger array, namely the array that we received at the beginning. So we're going to want to declare indexes for both the array 1 and array 2. So let's call int I1 for the first array, and let's do the same thing for the second array. And let me fix these comments. There we go. Okay, so now oh my god, that phone is going to drive me nuts. So let's loop through the our initial array. So just array, not array 1 or array 2. So we will want to be moving through while I is less than size. And we'll copy this comment over. And we want to compare the first element of the two arrays, and whichever element is smaller between the two will go in the I position of the parent array. So we're going to be rewriting the parent array. Also, let's set these two indexes equal to 0. Okay, so let's compare the first two elements. So we're going to use array 1. And let's say we're interested if array 1's ith element is smaller than array 2's ith element. And in the case of a tie, let's give the tiebreaker to array 1. So if array 1 is less than or equal to the element at array 2, we will assign the element in array 1. Another thing we will want to check is just to make sure that the value of I1, whenever we're about to make this assignment, is less than the size of array 1, because we don't want to go out of bounds. So the next thing we'll do is, in this case, we want to assign the parent array at the ith index to array 1 at that ith index, and then we will, array 1, this should be at the I1 index, and then we'll increase the I1 index. So now that when we make the next comparison, this should be I1 and this should be I2. So when we make the next comparison at I1, it will be at the first index. All right, so in our else condition, we'll also just want to make, in the else condition, we know that the element at in array 2 is smaller. So we'll just want to make sure that I2 is less than half 2 at this point before I make the assignment. And in this case, we will do the same thing where we assign the array at the I index to array 2 at I2, and then we will increase the I2 variable. So make sure that everything's closing in the right spot. So this should be closing the for loop, great. And At this point, we will have an array that is populated with sorted elements from both the array 1 and array 2 list. So I'm going to go down in this lower bracket and then finally make sure this closes the function. Great. So implement selection sort for the second array by yourself, and please email me or comment if you have any questions. Thanks. And that's the end of the video. I need to go respond to that phone call.